Good afternoon, my YouTube viewers. It's Crystal here. What I wanted to do was I wanted to do a code review, but I wanted to talk about the BernoulliRBM, which is the Bernoulli Restricted Boltzmann Machine. And basically, you can find this on the sklearn Python's machine learning library. And so I've got it called up here so you can see it. Now, the Restricted Boltzmann Machine is a legacy algorithm, which means that people don't really use that algorithm anymore. But if you want it, it's on sklearn. If you feel like you need to use it, you can. In the past, you could make a restricted Boltzmann machine or RBM in TensorFlow, but it was made under TensorFlow 1 and not TensorFlow 2, and a lot of the code in TensorFlow 1 is deprecated. So I saw the code in TensorFlow 1, but they had something called placeholder. I didn't really know how to replace the placeholder, so I just thought, well, I'm not going to worry about this. And then I found out quite by accident that sklearn has an RBM as well. So I thought, well, that's neat. So the thing about TensorFlow is supposed to be TensorFlow is more popular than sklearn, but sklearn does actually have algorithms in it that are not in TensorFlow, such as the Restricted Boltzmann Machine. So here it is in TensorFlow, so you can see it in TensorFlow. They give the parameters, they give the attributes, and you can see it says see also MPL, MLPR, and MLPC, so it's closely related to it. Well, it is a neural network, but it's closely related to MLPRs and MLPCs, except for it doesn't make predictions. If you wanted to make a prediction, then you have to use it with a classifier or a regressor. And so here's a little bit of code that you can use it where it doesn't make predictions. So if you feel like you need to use a restricted Boltzmann machine, then you can use it in sklearn, and you won't have to try to figure out how to do it in TensorFlow and convert TensorFlow 1 to TensorFlow 2, which is what you would need to do because these RBMs were originally written in TensorFlow 1. And one of the variables that's used, or functions that's used, is called placeholder. That's no longer in TensorFlow 2. So you would have to try to figure out how to convert TensorFlow 1 to TensorFlow 2. That's going to take a lot of time to do, and I just decided not to do it. So here's some sample code for the RBM, and the sample code was made by these authors Jan M. Daphne, Vlad Nikolai, and Gabriel Senon. So if you want to know how these authors have written this code, they give you some example on how to use the code. And one thing that I thought was really interesting was they used the MNIST dataset, but when they used the MNIST dataset, they manipulated the data. So they created a function called nudge dataset, and they created a function called shift, and so they wanted to manipulate the data. They were not really happy to just use the data as it was. I'm not sure exactly why that is because they didn't explain why they did it. They just did it. But here's the code here, and it's on sklearn, and they tell you how to do it on sklearn. So what I decided to do was I tried to use this code without a nudge and see what happens. So with the nudge, we'll just go ahead and use the code with the nudge, and we had a 93% accuracy with the nudge. But I thought, well, I would go ahead and try to replicate their code, but just use it without the nudge. So the first thing that we're going to do is we're going to import all the libraries that we need. And And the way you're supposed to do it is you're supposed to do it at the beginning of the program, which is what I did on this occasion. So from sklearn.neural import BernoulliRBM. From sklearn.pipeline, import pipeline. From sklearn.linear model, import logistic regression. From sklearn.datasets, import load datasets. From sklearn.model selection, import train test split. From sklearn, import metrics, import pandas as PD, import numpy as MP, and import matplotlib as .pyplot as PLT. So those are the functions, those are the libraries, and their modules that we will be using in this small little program. So we're going to use the MNIST dataset, which is a toy dataset, in sklearn. So xy equals load digits, return xy equals true, x equals np.asArray x, float 32, and then what we're going to do is we're going to normalize the data set. So when you normalize the data set, you take all of the data and you convert it to a value between 0 and 1. So x equals x minus x min over x max minus x min. And what that does is that converts all the data to 0 to 1. And then what we're going to do is we're going to split the data set into training and testing sets. So x train, x test, y train, y test equals train test split. X, Y, test size equals 0.2, random state equals 42, and then we're going to print out the shape. And then when we print out the shape, you see that the shape, you've got 64 columns, so that's 8 times 8. So, and then what we're going to do is we're going to create an RBM instance for each layer. So RBM equals BernoulliRBM, random state equals 42. And then we're going to create a classifier. Logistic equals logistic regression. Solver equals Newton CG. Max ITER equals 1000. Random state equals 42. Total equals 1. Then we're going to create a pipeline. CLF equals pipeline, steps equals RBM, and logistic. So the first thing you're going to do is you're going to run it through the RBM, and then after you've run it through the RBM, you're going to run it through the logistic. And then what we're going to do is we're going to train the data into the model. So CLF.fit, X train, Y train, and you can see there the pipeline is the Bernoulli RBM and then the logistic regression. So we're going to make predictions on the model. YPRED equals CLF.predict X test. That's YPRED. And then we're going to print the classification report, and so you see we have an overall accuracy of 87%, and then we're going to create a data frame that lists the actual values opposed to the predicted values. And then if you want to print the values, print the digits, we've got some code here that enables you to predict the digits. So the thing about the accuracy with the nudge is, I think it's 93 or 94%, 93%, and the accuracy without the nudge is 87%. So obviously adding that extra bit of code did actually improve the accuracy. These people who wrote the code are obviously a lot more knowledgeable about machine learning than I am. So I'm assuming that they created the nudge in there to improve the accuracy, because you can see the accuracy is improved without the nudge. And then what we're going to do now is, now that we've gone over the RPM, that's the Restricted Boltzmann Machine, if you take two RBMs and put them together, then what you have is called a deep belief network. And a deep belief network is another type of neural network. It's pretty old. It's a legacy. It's a legacy algorithm as well, but it's something that perhaps if you're studying machine learning and deep learning, it's something that you need to know just to give you a little bit of background. And they have more advanced algorithms that they can use instead, but it's still nice to see a deep belief network. And as I said before, a deep belief network is two RBMs placed back to back. So what I did was I took this code from the RBM. I took the code from the RBM and without the nudge. And then I modified it to make a DBM, because a DBM is two RBMs back to back. So the code is essentially the same. We are using the same libraries and modules. We're doing the same thing to our data. And the only thing that we're doing is instead of one RBM, we're going to have two. So instead of calling it RBM, we're going to call it RBM1 and RBM2. And we're also going to be using logistic regression as well. And we're going to create a pipeline. So when we create the pipeline, it's going to be DBN equals pipeline, steps equals RBM1, RBM2, 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 and logistic. So you've got two RBMs and one logistic. And then what we do is we fit the data, train the data, and you can see you've got two RBMs and one logistic regression. And then now we make predictions on the DBN, that's your deep belief network. And when we made the predictions on the DBN, you'll see that we have an accuracy of 79%. So when you have two RBMs back to back, your accuracy has actually decreased. So you would think that if you got more neural networks that it would improve your accuracy, but that's not necessarily the case. And then we create a data frame that lists your actual values as opposed to your predicted values. And then you can look at the digits as well. And then I didn't get to use DBM because DBM is something we made up, so I just said RBM1. But if you want to look at the digits, you can. So that's it. So what we've done is we've talked about sklearn's Bernoulli Restricted Boltzmann Machine. We looked at the code without a nudge for this to create one and make predictions on it. And then we talked about how you can take two RBMs and put them back to back and make a deep belief network. And we've covered the code for both. We covered the code on the RBM, BernoulliRBM, and then we covered the code for a deep belief network. And it's interesting to note that the accuracy with the RBM was greater than the accuracy was with the deep belief network. And so, you know, more is not always better. That's just something to take away from you. And I also want to say something that I had been 2 times now. I have looked on the Saturn Cloud website to try to get sample code to understand things. And 2 times, both times that I've looked at the Saturn Cloud website, the code was wrong. And Saturn Cloud, that's a machine learning website where you actually have to pay to use it. And you'd think that if you're actually having to pay to use Saturn Cloud, that they would get good code. They would actually get code that works. And the 2 times now, the code hasn't worked. 2 times now. So I'm just I just wanted to bring that up. Definitely with the DBN and the RBM, the code just doesn't work. And so I just felt I needed to mention that, because you would think that if these businesses who are charging people money to use their machine learning website and use their machine learning platform, that they would have usable code, but the code isn't usable. And I can understand that some code is deprecated, because all of the libraries, they're always being updated, and since the libraries are being updated, sometimes you're going to get deprecated code. But I just think that Saturn Cloud should make more of an effort to make sure that the code works before they put it on their website, especially since people are having to pay to use that. And that's just my gripe. So I'm going to go ahead and conclude this video, because we've talked about RBMs and DBMs and sklearn. And so thank you so much to my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. If you want to be notified whenever I make a new video, then please tap onto the bell button next to the subscribe button. And thank you for watching my video. I look forward to making more videos for you in the future.